This is Gubbi online classes. So welcome everyone to the Ncert 10th standard syllabus and Cbse 10th standard syllabus. So for mathematics and science. So in the last class of polynomials, we had discussed problems on polynomials which are for 3 marks and 4 marks. So those problems were scientifically picked up from the various publications or books, and they were presented in front of you. So those range of problems what I am discussing are very important. Those problems may directly come in your exams, or that type of problems may come in your exams. So therefore the theory understanding before each and every problem plays a very important role. So please understand the theory behind the problem and then attempt the problem to get the solution, right? So in this polynomials chapter, what most of the students, what they do the fault is, they do the process of division. What they do is, somewhere they will make some silly mistakes and the entire process of division will be wrong. So please be very careful in the division process. So in all the problems what I have done, I have shown you the division process for each and every problem. So other than that, you should also practice that. So once you practice division, it will be easy for you, you will get a hold. Okay, in today's problems we will be going with some more very important problems on polynomials which are for 3 marks and 4 marks. So in the yesterday's session, I had discussed regarding a problem. What should be subtracted from a given polynomial so that it is exactly divisible by the given polynomial. So what you did is, when you got the remainder, you converted that into negative sign. That is, you got maybe 14 as the remainder. You did it minus 14 and then you subtracted from the polynomial so that that polynomial is exactly divisible by the divisor. So here in today's problem, one particular type of problem may come like that. What should be added to? That's the thing. What should be added to the polynomial so that it is exactly divisible by the divisor. So in this category of problem, you have to divide the polynomial by the divisor, and the remainder what you get at the end should be directly subtracted from the, that is directly added to the polynomial. So that's remainder means the polynomial is that much less than less when it wants to get divided by the divisor. So that is, the polynomial should be added, directly added with the remainder so that the entire polynomial is going to get divided by the divisor. So here, if you want, there are two type of problems in this. What should be subtracted and what should be added. So what should be subtracted I have discussed in the yesterday's class, and in today's class I am telling you what should be added. So what the remainder you get directly added to the polynomial, that's all. Whatever sign is there, irrespective of the sign, what the remainder gets directly added to the polynomial so that it gets exactly divided by the divisor. So there are the two types of problems. So in the next classes, if I get the problem, I will surely present it on the board. Okay, today we will go with 5 problems which are very important. So on board I have already, the problem is there. We will go with this. So if x cube minus 6x square plus 6x plus k is a constant here. So it is a cubic polynomial. So it is in the standard form. So at last it is a constant. Is completely divisible by x minus 3. So he has divided this. So this is the polynomial, and he is going to divide this polynomial by x minus 3. So this polynomial is exactly divisible, that is completely divisible by x minus 3. If this is the case, find the value of k. So where k stands, k is at the constant, that is the real constant. So okay, let us go with this. It's a very simple problem. So let p of x is equal to x cube minus 6x square plus 6x plus k. So let this be the polynomial p of x, and let the divisor be g of x is equal to x minus 3. So now we will divide this polynomial p of x by g of x. Let's see what we get as the remainder. Okay, so x cube minus 6x square plus 6x plus k is the polynomial. We have to divide this polynomial by x minus 3. So x into what gives you x cube is, that is x square. X into x square is x cube, minus 3 into x square is minus 3x square. So we have to subtract this from this. So sign changes. So plus x cube minus x cube cancels. Minus 6x square plus 3x square is minus 3x square. So we will take down these two terms with sign plus 6x plus k. So now x into what gives you minus 3x square. So that is minus 3x. X into minus 3x is minus 3x square. Minus 3 into minus 3x is plus 9x. Okay, we have to subtract this from this. So sign changes. So minus 3x square plus 3x square cancels. Plus 6x minus 9x is minus 3x plus k. So here the degree of the divisor is equal to the degree of the remainder. Therefore, still the division process continues. So x into what gives you minus 3x. So it is minus 3. X into minus 3 is minus 3x, and minus 3 into minus 3 is plus 9. So you have to subtract this from this. So sign changes. So okay, minus 3x plus 3x cancels. So here k plus 9 is the remainder. You have to write the term which is present in the first expression, then that term you have to write in the second one. So it is minus. So it is k minus 9. So you have got k minus 9 as the remainder. So what the question tells you in the data. So this polynomial is completely divisible by x minus 3. So that's the statement given there. So here x minus 3 is a factor of that is x cube minus 6x square plus 6k plus k. So this is completely divisible. That's the meaning here. Is completely divisible by x minus 3. So the x minus 3 is a factor of the polynomial. It should be a factor of that polynomial. So when this divides this polynomial being a factor of this, then we should get the remainder 0 only. Without in the sense we have to 100% get the remainder as 0. So therefore, in place of k minus 9, it should be 0. So let us equate k minus 9 equal to 0. So k is equal to 9. So this is the value of 9, that is k. So very simple logic here. He has clearly told us that it is completely divisible by x minus 3. So this polynomial is completely divisible by x minus 3 means x minus 3 is a factor of this. Therefore, remainder should be compulsory equal to 0. So as we have got this remainder as k minus 9, we will equate k minus 9 equal to 0. So therefore, k is 9. So therefore, value of k is 9. So this is the answer. It may be asked in the examination for 2 marks. Right, we'll go with the next problem. Divide 6x cube plus 2x square minus 4x plus 3, a polynomial, by 3x square minus 2x plus 1. 3x square minus 2x plus 1, and verify division algorithm. Right, so this is the simple question here. So it is for 2 marks again. We have to divide this polynomial. We have to divide this polynomial by this polynomial, and we have to verify the division algorithm. So it's easy. So it will be asked in your examination for 2 marks. So they have not named the polynomials, so therefore name both the polynomials. So let p of x is equal to 6x square plus 6x cube plus 2x square minus 4x plus 3. Let this be p of x, and g of x is equal to 3x square minus 2x plus 1. So this is the dividend and that is the divisor. So let us divide this. Let us get the quotient and the remainder. Then we will verify division algorithm. So 6x cube plus 2x square minus 4x plus 3, and this is 3x square minus 2x plus 1. Right, let us start the division process. 3x square into what gives you 6x cube. So it is 2x. 3x square into 2x is 3. 2 side is 6. X square into x is x cube. So 3x square into 2x is 6x cube. Minus 2x into 2x is minus 4x square. Plus 1 into plus 2x is plus 2x. So we have to subtract this from this. So therefore sign of every term is going to change. Plus 6x cube minus 6x cube cancels. Plus 2x square plus 4x square is 6x square. Minus 2x minus 4x is minus 6x, and this is plus 3, which is taken down, right? So we will continue the process. 3x square into what gives you 6x square, that is 2. 3 into 2 is 6. X square into no variable is there, so it becomes 6x square itself. Minus 2x into plus 2 is minus 4x. Plus 1 into plus 2 is plus 2. So again, you have to subtract this from this. Sign changes. Right. Plus 6 square minus 6x square cancels. Minus 6x plus 4x is minus 2x. Minus 2 plus 3 is plus 1. So this is the remainder. So now let us write down the quotient and the remainder. So quotient is equal to q of x. Let us call it as q of x, that is 2x plus 2, and we'll call this remainder. So we'll give a name to the remainder. So remainder is equal to r of x is equal to minus 2x plus 1. So this is the quotient and the remainder what we have got. Now we will verify division algorithm, that is the relationship between the dividend, the divisor, the quotient and the remainder. So that's the relation. That relationship is known as division algorithm. By Euclid's division algorithm. By Euclid's division algorithm, P of x is always equal to g of x into q of x plus r of x. So this is the Euclid's division algorithm. So P of x we will write what it is given, that is 6x cube plus 2x square minus 4x plus 3 is the P of x. So we will write the g of x, that is the divisor, that is g of x. So it is 3x square minus 2x plus 1, keep it inside brackets, into q of x is the quotient what you have got, that is 2x plus 2, plus r of x is the remainder what you have got, that is minus 2x plus 1. Right. So here 6x cube plus 2x square minus 4x plus 3 is equal to, so this expression and this expression has a multiplication sign in between, so we have to multiply each and every term here. Right. So 3x square into 2x is 6x cube. 3x square into plus 2 is plus 6x square. Minus 2x into plus 2x is minus 4x square. Minus 2x into plus 2 is minus 4x. Plus 1 into plus 2x is plus 2x. Plus 1 into plus 2 is plus 2. Now multiply this binomial by plus sign, that is we assume that 1 is here. Plus 1 into minus 2x is minus 2x. Plus 1 into plus 1 is plus 1. Okay. 6x cube plus 2x square minus 4x plus 3 is equal to, so this is the single term with the degree 3, so no other term is there. So let us write this same thing. Plus 6x square minus 4x square is plus 2x square minus 4x plus 2x and minus 2x. So minus 2x plus 2x cancels. remaining is minus 4x, and we have to simplify the constants, that is 2 and 1, so that becomes 3. So here LHS is equal to RHS, hence it is verified. So this is how we have to verify the Euclid's division algorithm when a polynomial and a divisor is given. So it's for 2 marks, very important. Right. If two zeros of a polynomial, x cube plus 3x square, x cube plus 5x square plus 7x plus 3, or minus 1 and 3. So, two zeros of a polynomial, that is x cube plus 5x square plus 7x plus 3. So, if you look at the polynomial, the highest degree of the polynomial is 3. So, therefore, it has 3 zeros. So, among those 3 zeros, there are 2 zeros given to us. One is minus 1 and another is 3. So, what we have to do is find the third zero. Find the third zero. So in the previous problem, I hope you remember, a polynomial was given, a cubic polynomial, and you were given 2 zeros, and you were asked to find out the remaining 1 zero. So here 2 zeros are given, and you are asked to find out the remaining 1 zero. So a very simple trick is followed here. You have to just observe. Right. So what we have to do is, we have to consider this as P of x. We have to consider this as P of x. So for this P of x, we have 3 zeros. That is 1, 2 and 3. That is 3 zeros. Among these 3 zeros, minus 1 is one of the zero, minus 3 is another zero. You have to find out this third zero. This is the thing he is asking us. So what we have to do is, as these two are the zeros of this polynomial, we have to search a quadratic polynomial where these two numbers are also the zeros of that quadratic polynomial. So for that, what we have to do is, using these two, we have to find out a quadratic, that is a quadratic polynomial. So here, these two are the zeros of this cubic polynomial, as well as these two are the zeros of this quadratic polynomial also. It happens. So when we divide this P of x by this quadratic polynomial, we are going to get a quotient. We are going to get a quotient, and that quotient, when we equate that to 0, that will be the third zero. This is the entire mind map of this particular problem. This is how it goes. So this will be in our mind while solving the problems. So step by step we'll be explaining this on the board, but this entire mind map of the problem should be present. Okay, I hope you understood. For P of x, we have 3 zeros. Out of 3 zeros, 2 zeros have been given to us, and he is asking us the third zero. So here we have to create, or we have to establish a particular quadratic polynomial where minus 1 and minus 3 are also the zeros of this quadratic polynomial, and as well as they are the zeros of this P of x also. So when we divide this P of x by this quadratic polynomial, what we get a quotient. And when we equate that quotient equal to 0, we get the third zero. This is how it goes, right? So please remember the mind map. Let us go with this. So if the zeros of a polynomial, so polynomial is not named, so let us name the polynomial. So that P of x is equal to x cube plus 5x square plus 7x plus 3 is the given polynomial. So two zeros are given. So here -1 and -3 are two zeros. -1 and -3 are the two zeros. Okay. So therefore x, we have to be very careful here. X plus 1 is equal to 0. Because -1 is the 0, therefore x plus 1 will be equal to 0. Because when you retain x here, as you make x as the subject, when you transpose plus 1 to the RHS, that becomes -1. That -1 is given there. So therefore, when you take -1 inside, then it becomes x plus 1 is equal to 0. And x plus 3 is equal to 0. So this and this both are equal to 0. So therefore, their product will be also equal to 0. That is x plus 1 into x plus 3 will be equal to 0. So x into x is x square, x into plus 3 is plus 3x, plus 1 into x is plus 1x, plus 1 into plus 3 is plus 3, which is equal to 0. So x square plus 3x plus 1x is plus 4x plus 3 is equal to 0. So here we have successfully created a quadratic polynomial whose zeros are, that is -1 and -3, which are also the zeros of this cubic polynomial. So now we have to divide this p of x by this g of x. So let g of x is equal to x square plus 4x plus 3. So this is the divisor which is ready with that. So we will divide this. So let us carry the division process. So polynomial, let us write it down, that is the dividend x cube plus 5x square plus 7x plus 3 is the dividend. So this is the divisor, that is x square plus 4x plus 3. So let us start the division process. X square into what gives you x cube, that is x. X square into x is x cube plus 4x into x is plus 4x square plus 3 into x is plus 3x. Okay, we will subtract this from this. So sign changes. So plus x cube minus x cube cancels. Plus 5x square minus 4x square is x square minus 3x plus 7x is plus 4x plus 3. So this is the remainder we have got. So we will continue the process. X square into plus 1 is, that is plus x square, plus 4x into 1 is plus 4x, plus 3 into 1 is plus 3. So this is minus, and this is minus. All the three terms are going to get cancelled, and the remainder what you have got is 0. So which is the third 0? That is how we have to identify here. So here we have got the quotient as x plus 1. So quotient is equal to x plus 1. So therefore x plus 1 is equal to 0. We have to equate the quotient equal to 0. So therefore x is equal to minus 1. So therefore minus 1, that is minus 1 and minus 3 are the three zeros. X is equal to minus 1. So minus 1 is the third 0. Alright, so this is the problem. Very, very, very important. You have to go with this and practice this and understand the theory behind this. Right, we go with the next problem, very important. If alpha and beta, if alpha and beta are the zeros of the polynomial, the zeros of the polynomial 6y square minus 7y plus 2. So alpha and beta are the zeros of the polynomial 6y square minus 7y plus 2. Find the quadratic polynomial. Find the quadratic polynomial, I'll write the short form, whose zeros are 1 by alpha and 1 by beta. 1 by alpha and 1 by beta. Right. So let us get into this. Let us frame the mind map for this. What is to be done? We will discuss and then we will proceed with the problem. If alpha and beta are the zeros of the polynomial, so okay, 6y square minus 7y plus 2 is the given polynomial for you. So these are the two zeros. One zero is alpha, another zero is beta. For this quadratic polynomial, these are the two zeros. One is alpha, another is beta. Now we have to frame a quadratic polynomial, that is ax square plus bx plus c, whose zeros are 1 by alpha and 1 by beta. So if alpha and beta are the zeros, then this is the quadratic polynomial. For this quadratic polynomial, alpha and beta are the zeros. Now we have to frame a quadratic polynomial whose zeros are 1 by alpha and 1 by beta. In the sense, the reciprocal of alpha is 1 by alpha, the reciprocal of beta is 1 by beta. If the reciprocals of alpha and beta are 1 by alpha and 1 by beta, then what will be their quadratic polynomial? We have to find. So this is the quadratic polynomial, alpha and beta are the zeros. If 1 by alpha and 1 by beta are the zeros of any polynomial, then find out that quadratic polynomial. So that quadratic polynomial will be in the form of ax square plus bx plus c. So we will go with the problem. So using the data of this, we will reach this. I'll show you how it comes. It's very simple. Okay. So let alpha and beta be the zeros of 6y square minus 7y plus 2. So this is the given polynomial, right? So here in 6y square minus 7y plus 2, a is equal to 6. The value of a is 6. The value of b is minus 7 and value of c is 2. The value of a, b and c we have taken. Now we will find the sum of the zeros. Sum of the zeros is equal to, that is alpha plus beta, which is equal to minus b by a. I hope you remember the formula. The sum of the zeros of a quadratic polynomial, that is minus b by a. So that is, I will put this minus here, put the bracket, b value is minus 7 by a value is 6. So that becomes 7 by 6. So what is the value of alpha plus beta? It is 7 by 6. Now we will take product of zeros. Product of zeros. Now product of zeros is alpha into beta, that is c by a. C value is 2 and a value is 6. That is 2 ones are 2 3s are. So that is alpha beta is 1 by 2. Alpha plus beta is 7 by 6. Okay. Oh, sorry. 1 by 3. Right. So it is 1 by 3. Silly mistake. You have to be careful. So product of zeros we have got and sum of the zeros we have got. Now let us frame the quadratic polynomial whose zeros are 1 by alpha and 1 by beta. 1 by alpha and 1 by beta. Right. So before going into that, I will give you a hint about it. So required quadratic polynomial is in the form of x square minus 1 by alpha plus 1 by beta into x plus 1 by alpha beta is equal to 0. So okay, so this is the required form of the polynomial, that is if the zeros are 1 by alpha and 1 by beta. So sum of the zeros will be x plus product of the zeros will be the required polynomial. So here we need the value of 1 by alpha plus 1 by beta, and we need the value of 1 by alpha and beta. 1 by alpha, beta, we need this. So before writing this, we will find the value of this and this. We will get ready with these values, and then we will write the required quadratic polynomial. Right. So now we will take sum of zeros. Sum of zeros is equal to 1 by alpha plus 1 by beta. So that comes alpha into beta is alpha beta. 1 by alpha into alpha beta is alpha cancels, only beta remains, plus 1 by beta into alpha beta is beta cancels and alpha remains. So that is alpha plus beta by alpha beta. So this is the sum of the zeros of the required quadratic polynomial. Right. We will take the product of zeros. Product of zeros is equal to 1 by alpha into 1 by beta. So that becomes 1 by alpha beta. So we have the value of that is alpha. Okay, here we have the value of alpha, we have the value of that is alpha plus beta, and we have the value of alpha beta, that is alpha plus beta ready, that's value of 7 by 6, we will substitute here. Alpha beta value is ready, that is 1 by 3, we will substitute here. When we simplify that, we will get this value because this is equal to this. So now we have alpha beta, so we will take the reciprocal of alpha beta, that becomes 1 by alpha beta. Okay. So required, we write the required polynomial, required quadratic polynomial with 1 by alpha and 1 by beta as zeros is given by x square, that is you can write like this, p of x is equal to x square minus 1 by alpha plus 1 by beta into x plus 1 by alpha beta. So p of x is equal to x square minus, so 1 by alpha plus 1 by beta can be written as alpha plus beta by alpha beta, that is alpha plus beta by alpha beta into x plus 1 by alpha beta. So in the next step we will put the values. So p of x is equal to x square minus alpha plus beta, value is ready, that is 7 by 6 by alpha beta, value is that is 1 by 3 into x plus 1 by alpha beta, that is 1 by alpha beta value is 1 by 3. So we will take reciprocals. So p of x is equal to x square minus, so here we can go like this, 7 by 6 into 1 by 3 reciprocal is 3 by 1, that is 3 ones are 3, 2 times it goes, so into x plus 1 by 3, when you take the reciprocal it is 3. So the polynomial is p of x is equal to x square minus 7 by 2 into x, that is 7 by 2 or 7x by 2 plus 3. So in the denominator we have 2, so we have to multiply the entire polynomial by 2, so that becomes p of x is equal to 2x square minus, that is 2 into x square is 2x square, 7x by 2 into 2 is 2 cancels, that is 7x plus 3 into 2 is 6. So this is the required quadratic polynomial which gives you the zeros which are in the form of 1 by alpha and 1 by beta. So this is very important, very important problem, because it will be asked for 3 marks. So one thing you can also do here, you can simplify the values here itself, that is alpha plus beta. You can simplify the value here itself, and then directly you can add the value, that is substitute the values here, so that these steps becomes less. That can also be done. It's not an issue. Okay, we'll go with the next problem. If 1 0 of a polynomial, 1 0 of a polynomial, 3x square minus 8x plus 2k plus 1 is the polynomial, is 7 times the other, is 7 times the other, 7 times the other. Find the value of k. Okay, this is a very important problem. For 3 marks, it is being asked in one of the final examinations of Cbse. Very important. If 1 0 of a polynomial, so this is a quadratic polynomial here, 3x square minus 8x plus 2k plus 1, maybe k is some constant here, that is entire 3x square minus 8x, this entire 2k plus 1 is a constant, not 2k is some constant or 1 is not, like that. Combined, taken together, 2k plus 1 is totally a constant, because after this you should get a constant. Let there be any number of terms representing that, but all those terms taken together will be a constant. So 2k plus 1 is a constant. So what has happened here is, 1 0 of a polynomial, 3x square minus 8x plus 2k plus 1 is 7 times the other. So it's very important here. 3x square minus 8x plus 2k plus 1 is the given quadratic polynomial. So better if you put a bracket like this. So it is in the form of ax square plus bx plus, this entire thing is c. This entire thing is c. So we have 2 zeros for this. So one is, let us take alpha, another is we will take as beta. So the condition is 1 0 of the polynomial is 7 times the other. So if alpha is alpha itself, then beta will be 7 alpha. You can take it like this. So 1 0 is, that is 1 of the 0 is 7 times the other. That is what the value we have here. This value multiplied by 7 times will be the other 0. For example, if first 0 is 1, then the second 0 will be 7. It is 7 times. If it is first 0 is 2, then the second 0 will be 2 7s are, that is 14, something like that. So if this is the condition, you have to find the value of k. So the k is at the place of constant. So you have to find the value of k. So I hope you understood. So this is the given quadratic polynomial. For this we have 2 zeros. Condition is 1 of the 0 is 7 times the other into 7, that is this. This 0 is multiplied by 7, that is this 0 multiplied by 7 will be equal to this 0. So 1 of the 0 is 7 times the other. So if this is the thing, find the value of k. So here you have to take the help of sum of the zeros and product of the zeros. So let p of x is equal to 3x square minus 8x plus 2k plus 1. Let this be the polynomial. So let alpha and beta be the two zeros. Let alpha and beta be the two zeros. So here alpha is equal to alpha itself. Let beta is equal to 7 alpha. So this is the condition I have done. Alpha, let alpha be alpha itself. Let beta be equal to 7 alpha, because one zero is 7 times the other. So here when we compare this with the standard form of the quadratic, that is standard form. So a is equal to 3, b is equal to, that is minus 8, and c is equal to, that is entire thing, that is 2k plus 1. So now we will take sum of zeros. Sum of zeros is equal to alpha plus beta. So here alpha is alpha itself plus beta is, that is beta is 7 alpha. So 7 alpha is equal to minus b by a. That is minus b by a, which is equal to minus b is minus of minus 8. Minus of minus 8 by a is 3. So this becomes alpha plus 7 alpha is 8 alpha is equal to 8 by 3. So this is the condition. So a alpha plus 7 alpha is 8 alpha is equal to minus into minus is plus 8 by 3. So 8 alpha is equal to 8 by 3. So 8 and 8 cancels. So alpha is equal to 1 by 3. So what is the value of alpha here is 1 by 3. Okay, we will take the product of zeros. So product of zeros is equal to product of zeros is equal to, that is alpha into beta, that is alpha remains alpha itself and beta is 7 alpha is equal to c by a. C by a is the formula to find the product of the zeros. C by a is, c is 2k plus 1 is equal to 2k plus 1 by a value is 3 there, okay, by 3. So alpha into 7 alpha is equal to, that is 7 alpha square is equal to 2k plus 1 by 3. 2k plus 1 by 3. So 7 into alpha value we have here, that is 1 by 3. 1 by 3 is equal to 2k plus 1 by 3. 7 1 is 7. 7 by 3 is equal to 2k plus 1 by 3. So denominators 3 and 3 gets cancelled. So 2k plus 1 is equal to 7. 2k is equal to 7 minus 1. So 2k is equal to 6. K is equal to 6 by 2. That is 2 1s are 2 3s are. So k is equal to 3. That is the value of k is 3 we have got. Okay. Okay. 1 minute. We have not squared here. Please, 1 minute, 1 minute. It's a small error. Okay, 7 into alpha is 1 by 3. That is 1 by 3 whole square is equal to 2k plus 1 by 3. So we are not squared in the last problem. Okay, okay, no problem. So 7 into 1 by 3 whole square is 1 by 9 is equal to 2k plus 1 by 3. 7 into 1 is 7 by 9 is equal to 2k plus 1 by 3. So we can do one thing. 1 times 3 times we can divide that. So that is 7 by 3. 7 by 3 is equal to 2k plus 1 by 1. So we multiply this, cross multiplication. So 3 into 2k plus 1 is equal to 7. 3 into 2k is 6k plus 3 1s are 3 is equal to k. So 6k is equal to 7 plus 3 gets transposed, that is minus 3. So 6k is equal to 7 minus 3 is 4. So k is equal to 4 6, that is 2 2s are 2 3s are, so therefore k is equal to 2 by 3. So the value of k is 2 by 3. So this problem was asked in the final exam of Cbse, maybe 2006 or 7 something. So it's a very important problem. So one problem of this category I have shown you. So we can create n number of problems of this category. So you have to practice the problem and understand the theory. It's very important. Okay. I hope you have enjoyed the entire session. So here these problems are very important. Please practice all the problems. See that you are getting ready for the test. So in this session I am going to complete this particular chapter, that is polynomials. So in the next tomorrow's session I will be starting with the most very important chapter in geometry, that is similar triangles. So Sunday, get ready for a polynomials test including all these problems, all problems including, that is problems from the textbook and problems from the non-textbook problem, that is please get ready with the test, practice all the problems. Each and every problem will be in one or the other way. Theoretically I have included all the problems in the question paper. It will be for 30 or maybe for 40 marks. So don't worry about the marks, get ready for the entire chapter. So I wish you all the best. So regarding another session of that is your 10th standard syllabus for first language Kannada, we are starting classes, video classes for first language Kannada. So along with mathematics and science, Kannada classes will also be, videos will also be put on the YouTube channel. So please subscribe the channel, put a like button on it. Stay home, stay safe and keep learning.